Hello everyone. Welcome to the today's topic, that is random forest. We will be learning random forest, and the agenda and the approach will be the will follow some sonar problem for the classification. So how we will tackle that problem? We'll start with the introduction to the random forest. Second one, explore and understand the sonar data set. The third one, loading the CSV file and the coding part accordingly. So today's lecture will be like introduction and then heavily on code basis. So starting with random forest. What is random forest? Random forest is the one of the most and popular and the powerful supervised machine learning algorithm. As we know, machine learning consists of three parts, that is supervised machine learning, unsupervised machine learning, and the third one is reinforcement machine learning. So we'll be tackling the supervised part, in which we'll be studying random forest. As we know, the random forest is capable of regression and the classification both. It can solve regression as well as the classification problems. On what basis it will decide whether it is a regression problem or the classification problem? As we know, the dependent and dataset consist of dependent and independent variables. If the independent variable is continuous, that is numerical, we'll call that problem as a regression problem. If the uh, dependent variable is categorical variable, we will call that as a classification problem. So decision tree solve both problems. It creates the forest with number of decision tree. In general, more the tree in the forest, the more robust prediction does, giving the higher accuracy to the machine learning user. So it is like random forest, as the name suggests, it is like a bunch of or collection of trees with heavily plantation. So it's like the basic building block of random forest is decision tree. One decision tree, collection of decision tree results into the random forest. So there are four approaches to build the random forest algorithm. The first one is information gain. Second one is Guinea index approach. So to tackle our sonar dataset problem, we will be using Guinea index approach. The third one is chi-square, and the fourth one is reduction in variance. Now, how does the random forest work? That is interesting. If a random forest, we grow multiple trees as opposed to a single tree in cart model. To classify a new object based on attribute, each tree gives a classification and that tree votes for that class. The random forest chooses the classification having the most vote and in the forest. And in case of regression, it takes average of the output by the different trees. Votes, that party will be declared as a winning party. So it basically uses the this majority voting technique. It is important. And again, there is another random forest is used for divide and conquer technique. It uses divide and conquer techniques. So it is also known as unstable machine learning algorithm. Now, as I earlier said, the machine learning or random forest part consists of decision tree. So we'll go through quickly through the decision tree. What is decision tree? So actually decision tree is very fun and easy to learn. It's a supervised machine learning algorithm mostly used for classification problem. It gives support to the classification as well as the regression part, that is CART, classification and the regression tree. So decision tree is a flowchart like structure where each internal node denotes a test on a attribute. So as we look at the tree, it consists of root node and it has leaf, it has terminal nodes. So it is we will be studying comparatively to the this tree. So each branch in the tree represents an outcome of a test. Secondly, each leaf or terminal node holds a class label, and the topmost node is a root node. It is called as a root node. A decision tree can be used to visually and explicitly to represent decision and the decision making. Now, what are the advantages of decision tree? It is simple to understand, interpret, visualize. The second advantage is variable screening or feature selection. Feature selection is one of the major part in the machine learning algorithms. The third one is little effort for data preparation. Okay, now we will go for the disadvantages of decision tree. There is overfitting problem due to the variance. As we know, decision trees highly chances are it will go under variance problem that can be solved using bagging and boosting. Those are the two techniques to solve the variance problems. Now, the greedy algorithm cannot guarantee to return the globally optimal decision tree. Can be solved by training multiple trees. Okay, so application of decision trees, prediction of renewal premium, whether the customer will pay or not pay, and the Titanic survey, very famous data set which consists of whether a person survived or not survived. It is also used for male or female classification. Prediction of home prices based on the rooms, area, location, city, etc. Difference and similarities between classification and regression tree. What is classification decision tree and regression decision tree? So, in classification, dependent variable is categorical. As we know, our dataset consists of rows and columns, and we call it as a attribute and the observations. So, dependent variable is categorical, meaning that whatever the datasets consist of dependent and independent variable, we predict from independent variable the predictor output variable. So the dependent variable is categorical in case of classification. While in case of regression, dependent variable is numerical. So classification use mode or class technique, and the regression uses mean or average technique. The splitting process results in fully grown trees until the stopping criteria is reached, but the fully grown tree is likely to overfit data, leading to poor accuracy on unseen data. We will see what is pruning and splitting while solving the problem. So growing a tree, like it's choosing features from the data set, applying condition for the splitting. It's like condition. If the age of example is age of person is greater than 20, less than 20, then do this. And if it is greater than, then do that. Like it is a structure. So knowing when to stop, it's better than pruning. So now there are some IMP terminologies in the decision tree. There is a greedy algorithm and pruning. We will solve that problem. We will get to know greedy algorithm and pruning. A greedy algorithm is the name suggests that always makes the choice that seems to be best at that moment. This means that it makes a locally optimal choice in hope that this choice will lead to a globally optimal solution. And the pruning is one of the most techniques used to tackle the overfitting. There are some noting points. Decision for making splits heavily affect the tree's accuracy. Decision criteria is different for classification and regression trees. So application, well, now we will go for the application of random forest. We saw some decision tree. Now we will switch to the random forest. Now, the application of random forest in banking sector, medical sector, stock market, e-commerce, image classification, voice classification, remote sensing, object detection, there is well-versed applications are for the random forest. So it is also called as ensemble machine learning algorithm. Uses divide and conquer method to improve the model. Uses the concept of majority votings, just like the elections, as I already said. So group of weak learner, the base on which random forest work is group of weak learner come together to form a strong learner. Each classifier is a weak learner and it comes to form together to form a strong classifier. Hence, reducing the variance and improving the performance. Some terms and definition, bagging and boosting are the some majorly used technologies for ensemble modeling to reduce variance and increase the accuracy, and it also helps in avoid the overfitting. So bagging or bootstrap aggregating is a machine learning ensemble meta algorithm designed to improve the stability and reduce variance and accuracy. The boosting part is a machine learning ensemble meta algorithm for primarily reducing bias and also variance. It's in supervised learning. Converts weak learner into strong learner, algorithm that achieves hypothesis boosting, quickly known as boosting. All these terms will be understanding while doing the practical. Hello everyone. In previous lecture we saw introductory part of random forest. In this session we will explore the dataset that is sonar. It will be used for our problem solving. So you can find it on UCI website. It is very famous website to get any dataset. So the sonar datasets consist of multivariate characteristics. It has real attribute characteristics, number of instances, that is number of rows 208, number of attributes, number of columns of 60, and it is associated with the classification part. So we will be solving this classification problem, and the two classes are whether it is a mines ray or whether it is a rocks. So that will be our problem to tackle. So now we'll start with the coding part. Without wasting too much time in the theory, I will zoom so that you can easily see my code. Okay, sonar dataset. We'll be studying sonar dataset. In this section, we will apply random forest algorithm to sonar datasets. And I will be following methodological approach, which majorly industries follows because the code get robust and the size and maintenance of the code becomes easy. So I will be using methodological or writing function approach. Okay, the dataset is first loaded to my spider environment. The string value is converted to numeric and the output column is converted from string to integer values of 0 and 1. This is achieved with the helper function load CSV and the string column to float function and the string column to integer to load and prepare the dataset. Then we will go for k-fold cross validation using the cross validation split function, then accuracy metric, and to evaluate the algorithm, we will use the evaluate algorithm helper function. So we will also use an implementation of classification and regression tree, that is CART algorithm adapted by bagging, including the helper function test split to split a dataset into groups. So my code will be like, it will be consist of multiple helper functions. On that we will solve this sonar problem. There will be some terminal or split or build tree data helper functions. A new function named random forest is developed that first creates a list of decision trees from samples and training dataset and then uses them to make predictions. So without wasting much time on theory part, I will start with the coding part. So let's start with the coding. As we know, any dataset pre-processing part is there. So we have to import some libraries or packages. So I will import random. Sorry, I will use another syntax like from random import seed. So these will be the packages I will be using multiple times in my coding. So from random import another package, that is rand range. This will be generating the random variables or random range. From CSV import reader package. Reader will be reading the files, that is sonar dataset. So another one is from, I will comment this as importing the packages. Now the first part is done. We have imported the packages. Now we will load the CSV file into our spider environment. For that, I will define a function def as we know, we define the function with def word. I will use load CSV function, helper function, and I will pass that file name to that function so that it will return. As a function is, it will accept some parameters and it will return whatever processing has done on that. So I will make an empty list of data set. The syntax will be like this. Then I need to open the file to read whatever the file content. So I will pass the file name with read mode, R for read mode, as file. Okay, now CSV reader. I will define a variable CSV reader that will consist of the data read from my CSV file. Now I will use for loop for loop in a row in which CSV dot reader. I will use for loop for traversing purpose so that all the data can be traversed and read accordingly. So if not row, continue. Dataset dot append. I will use an append method of list to append all the rows of the dataset. And as we know, the function takes parameters and return the calculation accordingly. So it will return the dataset. Okay, all set. This is my first function, helper function to load the CSV file. Now I will go for second function, helper function, which will be convert my string into the column to float. So I will be defining a function to convert string columns to the float. That's because, as we know, dataset consists of numerical and the categorical variable. So as to process the data, we have to convert those categorical variables to the numerical variables. This is very basic part. Now I will be writing a helper function to convert string column into the float columns. So the function and the syntax will be like this. I will define a function with def keyword, def string column to float column, and I will pass the dataset with the column parameter. Now the body part of this function consists of, I will define a class values variable string column to float. That is a column. Sorry, I will use for loop for the retrieving. For every row in the dataset, row, I will use indexing row column is equal to float. Float is the function to convert the inbuilt function to convert string to float, whatever the variable is passed. And I will call one method strip on that row. Okay, that's it. So my first helper function, that is to convert a string column to the float, is ready. Now I will go for another helper function, which is converting a string column to integer. So here also I will pass the dataset and the column. Okay. Now I will define a variable okay, I will define a variable called as class values, which will fetch the row values according to columns. I will use for loop for the traversing for every row in data set. Okay, this is the class value variable. Now I will define a unique variable which will be a set of class values. So we have the class values variable. Now we are defining a unique variable which is a set consisting of class values. Okay, now I will use a lookup and define a dictionary, empty dictionary. Now for every I value in enumerate is the function for traversing every value in the list. So the body part of for loop consists of, again I will use lookup and pass the values equals to I. Again a for loop for every row in dataset. For every row in dataset, find out the row and particular column using the lookup we have already defined. Okay, row column, I will pass column. And this function will return lookup. Okay, that's it. This is the function to converting string columns to integer. Now, further proceeding, I will be using. So, okay, that's it for this session. We'll continue further part in next session. So, in this session, we imported the packages, required packages, and load a CSV file using a helper function like load CSV. Then we define a string column to float function to convert string column to the float, and another function to convert string columns to the integer columns. Okay. Hello everyone. In previous part, we found out the helper functions and we built some helper functions like load CSV, string column, converting string column to the float, converting string column to the integer. Now we will proceed the further part. Okay, in this part, I will be splitting dataset into k-folds. As we know, k-fold cross-validation is one of the most important technique used in machine learning. So, I will be building a helper function to split a dataset into k-folds. Okay, I will define a helper function cross-validation. Split. Okay, which will accept our dataset and another attribute as column. Sorry, n folds. Whatever the folds I will be applying on the dataset, that I will pass as a n folds. Okay, now I will load dataset and dataset to split. I will define a variable dataset split, which will be a list, empty list. Okay, now I will create a copy of my dataset. because in future, in case if anything goes wrong, I can refer my original copy and I can get back my original dataset. So it's better to keep a copy of your dataset. Now I will define fold size variable, which will be an integer function passing the dataset, passing the length of dataset underscore copy. Now I will, for further processing, I will use dataset copy. Okay, fold size is defined. Now I will use for loop for the traversing. For I in range, range is the function to define the or traverse the variables. In folds, the body part consists of fold equals to, again defining a empty list, while length of fold is less than fold size. That's mean fold size, I will use a index equals to. Now the rand range, remember the package we have already imported, rand range we are using here. We are passing length of dataset, fold dot append. I am using append method for, and I am passing dataset copy dot pop. Pop is the function. Now I am passing index to that pop function. Now dataset split dot append fold. Now this is the my cross validation split function. It will return data, so whatever the dataset split it has. Okay, this is the function for cross validation split. I pass dataset to that function, and whatever folds I want, that is n folds, I have passed in variable. Now the next function I will define is to calculate accuracy of percentage. Calculate accuracy percentage. Define a function which is accuracy metric, and here I will pass actual values and predicted. Now I will define a variable which is correct equals to 0 for I in range length of actual dataset if actual I equals to predict. Now I am comparing this equal sign compares the actual predicted values to the actual values. Return correct divided by the float, and I will pass length of actual values multiplying with 100.0. Okay, this is the function to calculate the accuracy of percentage. So here we have defined a function using actual and the predicted function values. If those two values are correct, the count will goes and it will increase by 1 and it will return whatever this. Sorry about my spelling mistakes. Okay, that's it for the today. We'll continue further. Hello everyone. In this session, we will be splitting the dataset into training and test part. As we know, machine learnings learn from the trained data and we test models on the testing data. So it's better to split dataset into train and test dataset. So the function for splitting the dataset into train and test part, I will be using our helper function to do this task. Okay. Now, let's start with the coding part. Evaluate an algorithm using a cross validation split. In previous part, we have calculated that cross validation part. So that part we'll be using in this helper function. Okay, we will be defining a helper function called def evaluate algorithm. So I will pass dataset to that function and algorithm passing the whatever the folds I want in the dataset and args. Okay, the body part consists of defining a folds variable. I will use cross validation split where I will pass dataset and the whatever number of folds I want in the dataset in folds. Okay, now scores is equal to defining a empty list for every fold in folds to train set is equal to list folds train set dot remove fold. Defining an empty string or list for the training set. Now for every row in fold, row copy is equal to list passing the row. Now the row copy, now test set dot append row copy -1 equals to none. Now predicted is equal to algorithm and args, number of args. Args is an argument. So actual is equal to row of -1 for row in fold. Accuracy is equal to accuracy metric actual and predicted. Scores dot append accuracy, and this function will return scores. Okay, this is the function to evaluate an algorithm by splitting the dataset into train set and test set. Now I will use another helper function, that is splitting, test splitting. So split a dataset, based on an attribute and an attribute values. Okay, so def test underscore split, passing the index value and the dataset. Left right is equal to list, defining empty list for the left and right variables. For row in dataset, if row in dataset, if row index is less than the value left. Remember, we have learned a concept regarding the splitting. That's what we are doing here with left splitting and right splitting. So left dot append whatever the rows, else right dot append row. Now this function will return left and the right split dataset. Okay, that's it for the day. Hello everyone. In this session, we will be calculating the Guinea index. Remember that we already discussed about the 4 approaches to build random forest algorithm. The first one was information gain, second Guinea index, chi-square, reduction in variance. So I will be using Guinea index for our random forest problem. So calculating Guinea index will be we have data set. We know the loss function. Loss function defines or find out the difference between the predicted and the actual accuracies. So it's like Guinea index is the function is like loss function. So in this case, I will explain how to calculate the Guinea index. It's like data sets consist of multiple columns or attributes. So it will calculate with each data point in the data set in the column, and it will compare with others, that is splitting whether it is greater. If it is a greater, it will part on the right hand side, or it is less, it will part on left side. So that will make a if dataset consists of 900 data points, it will consist of 900 Guinea index. So, and whatever the majority is, the random forest work on majority votings. Whatever the majority votes will get, that data point we will consider as a Guinea index. So we will write a Guinea, calculating a Guinea index, we will write a function, helper function. So let's get into that. By writing a function define Guinea index now I will define a variable n instances. What it will do, it will count all samples at split point. So float sum of length consisting of group for group in groups. Now I will set Guinea equals to 0.0 initially. That is sum of weighted Guinea index for each group. For group in groups, size equals to float length of group. For size is equal to float length of group. Now there is precaution, because to avoid by dividing 0, we write a condition if size equals 0, continue. Score equals to 0.0. Now I will score the group based on the score for each class. So for class value in classes p is equal to row minus 1 for row in group. Count class val divided by the size. Score plus equals p star p. This will be like weight the group score by its relative size. So Guinea equals to 1.0 minus score multiply with size slash n instances. Okay, that's it. This is the function to return the Guinea value.